All right, let's dive into a real cosmic detective story. We're going to unravel the mystery of a visitor to our solar system, an object from another star that has astronomers buzzing, arguing, and basically rewriting the rulebook. Its name is 3I/Atlas.
Now, this is not just another comet. Seriously, from its speed to its size to what it's made of, 3I/Atlas is a total cosmic outlier. So let's follow the clues together and investigate the very strange case of this interstellar object.
Every good detective story has to start by identifying the subject, right? So who or, what is 3I/Atlas, and why did it immediately get the world's attention?
The 3I in its name tells you everything you need to know about how rare this is. It means it's only the third interstellar object we've ever confirmed, after Oumuamua back in 2017 and Borisov in 2019. The Atlas Sky Survey spotted it, which was amazing because it gave us an unprecedented heads up that a visitor was on its way.
So the first major clue that something was off, its absolutely incredible speed. It came screaming into our system at 58 kilometers per second. That's nearly twice as fast as the other two. This thing isn't just passing through, it is absolutely rocketing through.
And clue number 2, well, this one's even more striking. There's only a 0.2% chance, that's 1 in 500, of a random object from deep space happening to align its orbit so perfectly with the plane of our planets. An alignment that precise, that's a huge anomaly that got everyone talking.
Okay, so beyond its strange path, the real excitement for scientists is what this thing is made of. See, 3I/Atlas isn't just a rock. It's a pristine sample from a completely different and very old part of the galaxy. By tracing its path backward, astronomers figured out it probably came from the Milky Way's thick disk, a neighborhood of really ancient stars. This means 3I/Atlas could be up to 14 billion years old. I mean, think about that. It could be older than our entire solar system. It's literally a physical piece of galactic history, delivered right to our doorstep. So, the James Webb Space Telescope took a look at the gas cloud, or the coma, surrounding the object, and what it found was just astonishing. Our comets are mostly water ice, dirty snowballs. This thing? It's overwhelmingly carbon dioxide at a ratio of about 8:1. We have never, ever seen anything quite like it. So let's recap. We've got a fast, strangely orbiting, chemically weird comet. But this is where the mystery really deepens into a genuine, head-scratching paradox. The evidence for how big it is, it just doesn't add up. Okay, here's the contradiction. The Hubble Space Telescope, with its super sharp vision, tells us the solid core, the nucleus, can't be any bigger than 5.6 kilometers. Simple enough, but to produce the massive amount of gas and dust that we see pouring off of it, our physics models say the nucleus has to be larger than 10 kilometers. It literally can't be both. Something's gotta give. So, there are only 4 ways out of this paradox. 1, our best telescope is wrong. 2, our basic understanding of how comets work is wrong. Or you've got 2 much more dramatic possibilities. 3, the object shattered into a cloud of fragments when it passed the sun. Or 4, its activity isn't natural at all. And just when you thought it couldn't get any stranger, the plot thickened. This happened right after 3I/Atlas swung around the sun in late October 2025. As it came back into view, it wasn't quite behaving as expected. Scientists confirmed it. It got a small but very distinct push, an acceleration that couldn't be explained by gravity. Now, for comets, this rocket effect is normal. It's just gas venting off a heated surface. But the size of this particular kick was enormous. For it to happen, the comet would have had to shed a huge percentage of its total mass. And the cause of that kick? An absolutely stunning, complex network of at least 7 different jets. And the most bizarre part? It included 2 powerful jets pointing towards the sun, these so-called anti-tails. While there might be natural explanations, their sheer scale and complexity are just another major anomaly to add to the list. So you take all these clues, the orbit, the chemistry, the size paradox, the crazy jets, and it's no surprise that it has led to a fierce scientific debate. It really boils down to 2 completely competing theories trying to explain this cosmic visitor. So the mainstream consensus is that, look, it's a natural, if very, very strange comet.
I mean, with a sample size of only 3 interstellar objects, we should probably expect to find some weird ones, right? They argue the anomalies are simply new data that will help us expand our understanding of how comets work across the whole galaxy.
But then you have the counterargument, which is all about statistics. The argument goes that the odds of all these anomalies, the orbit, the size, the activity, all occurring together in one single natural object are just astronomically low. So low that we have to at least consider the possibility that it's not natural. And when you put 3I/Atlas next to the other two, you can really see why it's such a puzzle. Oumuamua was strange, but it was inactive. Borisov was active, but it looked pretty familiar. 3I/Atlas kind of combines the deep weirdness of the first one with the intense activity of the second, and it creates this uniquely perplexing object.
So where does that leave our investigation? Well, the scientific community is basically in a state of high suspense because the final verdict is quite literally on its way to us right now.
The whole mystery really hinges on one key question. Is the nucleus a single solid object, or did it break apart into a cloud of fragments? We have high-resolution images from spacecraft that sought flyby Mars that could answer this, but they haven't been released yet. The most crucial data is out there, collected, but not yet back on Earth.
So here's the timeline for when we might actually get some answers.
The key data from the JUICE spacecraft is expected in February 2026. Then NASA's Juno probe gets a look in March 2026. After that, our chances to see it from Earth will pretty much fade by mid-2027 as it speeds back out into the darkness of interstellar space forever.
And that leaves us with the ultimate question. Is this thing a priceless scientific time capsule from a star system billions of years older than our own, or is its bizarre collection of anomalies pointing to something else entirely? For now, the verdict is still out there, racing away from us into the void.